Hello everyone, my name's Alano and welcome to my Game Maker Studio tutorials. Today I'll be starting a new series of videos where I challenge myself to code intricate stuff using Game Maker Studio 2. The purpose of these videos is to bring Game Maker to its extreme limits and see what is or is not possible in this engine. And we're going to start off with the Mandelbrot Set. Now before I start, I am going to talk about complex numbers, which are composed of real and imaginary components. If you don't understand what a complex number is, I suggest you go ahead and pause the video, take some time to check what these are, and come back afterwards. Alright, back to the topic. If you don't know what the Mandelbrot set is, you can think of it as a bunch of complex numbers. Those numbers, when applied to a canvas of sort, can be used to generate extremely beautiful and intricate image designs. Great, so the first thing we're going to do is create the room where we're going to draw to. So in our rooms, well, Game Maker Studio 2 already has a room created, so we'll just go ahead and open this up. In the background, we're going to set it to white. Alright, and over here, we want to set the room width to 600 and the height to 600. We also want to enable the viewports, because 600 pixels by 600 is kind of small, and we want to upscale this a bit so we can see more clearly what we're drawing. So in the viewport 0 here, first off, we want the camera properties to be 600 by 600, and don't forget to check the visible tab. And the viewport properties, we want it to be 800 by 800. This should be a good starting point. Next, we're also going to need an object, so let's create an object, and we're simply going to call this control, since this object is going to control everything from the Mandelbrot set. In here, we're going to add a create event. We are also going to add a draw event. At this point, we can start working on the Mandelbrot set itself. Like I said earlier, it's a very simple set that consists of complex numbers. But how do we decide if a complex number belongs or not to the set? Well, we first try using it in the following equation, where z is equal to c times c plus c. And here, c is our complex number. All right? We then use the result z in the following equation, where z prime is equal to z times z plus c. Here, z is our previous result, and c is still our same complex number. We then repeat these steps to get z double prime, which is equal to z prime times z prime plus c. Now we keep repeating these steps about a dozen times. If the result never exceeds a small fixed value, say 5 or 10, we can assume that the complex number belongs to the Mandelbrot set. Conversely, if the result exceeds that fixed value and becomes a large number, we can be sure that the complex number doesn't belong to the set. Now you might be wondering, how do I choose the value of the complex number? Well, that depends on what we want to do with the Mandelbrot set. If we want to generate a fractal image with it, which is what we want to do, we can use the x and y coordinates of pixels in our room as the real and imaginary components of that complex number. For instance, c is our complex number, and it's equal to x plus iy. Here, x is our x component, coordinate in our room, and imaginary y is our y coordinate in our room. However, we can't use the x and y coordinates directly. I mean, we could, but we'd end up with an image of the Mandelbrot set that is so far zoomed out that it would barely be visible. So by dividing the coordinates by a larger value, say a zoom, and we're going to set this to 600 because we're going to need it, we can zoom in the image. We can also move around the fractal by subtracting small numbers from the coordinates, say pan x, and we're going to set this to 0, and pan y, which is also going to be 0. Now that the theory is out of the way, let's go ahead and do some coding. All right, so the first thing we want to do is set up the program. So in the create event of our control object, we're going to go ahead and set up. We already have the zoom, pan X, and pan Y variables. Next, we want to disable the application surface. So application surface enable, and let's set this to false. Now, the reason I disable the application surface is to manually draw what I want to draw to the screen. Since the process of making a Mandelbrot set is extremely resource hungry, so we want to help GameMaker as much as possible, and you'll see why soon enough. Next, we're going to create a surface. So display is equal to surface create, and we want the surface to be the room width as well as the room height. All right, another variable we're going to need is iterations, which is going to be the number of calculations we want to do. And let's set this to a low number in the beginning. All right, so that's it for the setup. Let's go ahead in the draw event. This is where all the magic happens. So we're gonna say draw the Mandelbrot set. Oh, and by the way, the Mandelbrot set is named Mandelbrot in honor of Benoit Mandelbrot. He's a French guy, and he's the one who drew the first fractal of the Mandelbrot. All right, so first off, when we use surface, we always want to check if it exists. So if surface exists, and we want to check for the display surface, actually, if the surface doesn't exist, yeah, that's better. So if the surface doesn't exist, we want to go ahead and create it. So display is equal to surface create. All right, and we're going to set it to room width and room height, just like in the create event, like so. And if it does exist, then we're going to write the rest of our code. So here we want to check every pixel of the room. So we're going to start with a for loop and say var x is equal to 0. We start at, not y, I said x. Var x is equal to 0, so we start at the first x coordinate pixel. As long as x is smaller than room width, sorry about that, we increment x. And in here, for each coordinate on the x-axis, we want to check for the coordinates on the y-axis. So var y is equal to 0. We start at the first one. Y is smaller than room height, like so. We then increment y. There we go. Now, we're going to set up a temporary variable. We're going to call this one belongs. And we're going to use belong to set, which is a script we haven't written yet. Let's call it belongs here. And in here, we want to pass in our x and y coordinates. So x and y. But like I said earlier, we can't just use the x and y coordinates. We have to divide them by our zoom and add our pan x to it. Well, pan x for the x coordinate and pan y to the y coordinate, plus pan y. There you go. After that, we want to set the surface target, surface set target, and we want to set it to the display surface. This way we're going to draw to the surface. So if the pixel that we are selecting belongs to the set, because the function here is going to check if the pixel belongs to the Mandelbrot set. So if it does belong to the set, we are going to first set the draw color to black. So see black. And after that, we want to draw a single point. Draw point, yep, at the X and Y coordinates. All right, and after that, surface set target. Once this is done, we want to surface reset target, like so. Next up, we want to create the belongs to set script. So let me copy this here. Let's create a script, paste this here. We're also going to paste this up here. In the script, we want to pass in two arguments, the X and Y coordinates. So let's do just that. Var X is equal to argument 1, 0 actually. Var Y is equal to argument 1. We are also going to need a real component, which is equal to X in our room. We are also going to need an imaginary component, which is equal to Y in our room. All right, so after that, we need a for loop. So var I is equal to 0. As long as I is smaller than control.iterations, I plus plus. And this is where our, sorry about that. This is where our equation comes in handy. The Z is equal to C times C plus C. All right. So let's do the just that. We're going to start with a temporary real component, and we're going to call it real times real minus imaginary times imaginary plus X. Once this is done, we want to do the same thing with our temporary imaginary. Temp here. I gotta make sure I don't make any typos, because this is kind of a complex equations here. So we want 2 times our real component times our imaginary, and real has an underscore before. 2 times our real component times our imaginary component plus Y. After that, our real component is equal to our temporary real, and our imaginary is equal to our temporary imaginary. Like so. Now, we want to check if it's within the set or not. So we go ahead and write if our real times our imaginary is smaller than 5, we want to return true. Return true. Else, return false. Now that this is done, one last thing we need to do is actually to go inside our room and put the control object inside the room. So let's go ahead and test this out. We should get some results. Oh, and we seem to be having some problems here. Nothing is appearing on the screen. So let me just go back to our code here. Oh, okay, so see here. I set the target to display. I draw to the target, to the surface, that is. After that, I reset the target. But there's nowhere that I actually draw the surface to the screen. So let's do this just now. Right here after the for loop, we're gonna go ahead and draw surface. We want the display surface, and we want to draw it at the 0 and 0 coordinates. Great. Let's save and test this again. All right, so that's nice, but it's not quite exactly what we're used to when we're talking about a Mandelbrot set. So I'm guessing the pan and the zoom must be off. So let's go ahead and change these variables, okay? So let's set our zoom to 200 and our pan x to -2 and our pan y to -1.5. Control save and let's try this out. All right. Now, as you can see, we're getting closer and closer to what we're used to when we're talking about a Mandelbrot set. Now, you might be wondering, why does it still not look the part? Well, it's actually pretty easy. It's because we're only iterating 10 times on each pixel. So if we go ahead and put 100 here and run the game again, we're going to see a huge difference. There you go. Ain't that beautiful? But it's still only black and white. It would be nice if we could actually put some color in. So we're going to go ahead and do just that. First thing we're going to do to add some color is go into the belongs to set script. And instead of this here, we're going to remove this. We're going to say return false here. And inside the for loop, if the real times the imaginary, is it right? Yep, it is. Real is good also. Is greater than 5. We're going to return a percentage. Okay. So we're going to return I divided by control dot iterations times 100. Now that this is done, let's go to the draw event. Right here, we're going to go ahead and say, instead of if belong is true, because this script here no longer returns true or false, it now returns a percentage. Oh, actually, here, return false, this should be 0. Now, it either returns 0 or false. So, if belongs is equal to 0, we draw we set the color to black and we draw a point at the x and y coordinate. Else, if belong is something else, we're still going to draw a point, but we're going to draw some color depending on the percentage value returned by the script here, which is stored in the belong variable. All right, so var v for value is going to be 255 times belongs, right here, divided by 100. So here we're getting a percentage from the belong percentage with the 255 maximum, because we're going to set the color with hue and saturation. Sorry about that. So draw set color. We're going to make color HSV for hue saturation value. Here we're going to set the hue to V. We're going to set the saturation to 255, and we're going to set the value to V, like so. And after that, we're going to draw a point at the x and y coordinates. Control save, and let's check this out. Oh, variable control V not set before reading it. Oh, I misspelled V here. You guys probably saw that before I did. Again, control save. And this should now work. There you go. Isn't that pretty? Now, of course, you can go ahead in the create event and play with these values here to have different results. So say I want to zoom in. Let me bring this up. Say I want to zoom in here. I want to see a close-up image of this here. Okay? So for this, we're going to, well, first close this. We're going to set the zoom to be, say, 3000. We're going to set the pan x to be 0.7 and the pan y to be 0.6. And we're also going to up the number of iterations to 300. So we have a better quality image. Control save, and let's run this. Alright, so there we have it. If you've been following along, you should end up with the exact same result as this. And if you wanted to, you could always play with these 4 variables and get different result. Pan X and Pan Y is going to move the image around. Zoom is going to zoom into the image. And iteration is going to change the pixels and make it, well, cleaner and cleaner. The more iterations, the further you can zoom in, and so on. The thing is, it might not look like it, but it's pretty resource intensive, the process of generating these images. I have a pretty high-end computer, and this simple 600 pixels by 600 pixel image took my computer about 3 to 4 minutes to generate. And I've tried beforehand having an image with 5,000 iteration at a zoom of 10,000 to get a really colorful and awesome image. Because you can see here, we got some red and blue, not just green. And I wanted to see this. But GameMaker took about 25 minutes just to generate that. Insane, right? So, in conclusion, was I able to generate a fractal image using the Mandelbrot Set and GameMaker Studio? Yes, I was. Do I recommend it? No. Unless you want to simply show a pixelated, simplified version of this image. The reason is, GameMaker is simply not powerful enough to do this type of thing. Or maybe it's because, well, I have too much calculations done in the draw event. So, that's my question to you guys. If any of you has, well, ideas on how to upgrade this code and make it even more resource efficient, go ahead and post it below. I'm curious to see your experiences with this. Alright, so that's about it for this video. If you liked what you saw, don't forget to leave a like below and consider subscribing to my channel if you want more videos of this sort. And also, you can leave a comment below with ideas for next coding challenges I could do. So I have some ideas of what to do next, but I'm always open to your suggestions. So thanks a lot for watching and see you next time.